Okay, team, I think we can start now. Let me share my screen. Okay, team, so let me start from my introduction. So, hi everyone, my name is Varun Gupta. I have almost 15 years experience in the IT industry. I started my journey as a developer and then eventually moved to training domain from last 11 years into corporate training. So, I have done training on different technologies, majorly on full stack, .NET, Java, Mean, Monstack. I'm also certified in all the three major cloud, Azure, GCP, and AWS, and I'm also MCT. That's about me. So today we are here to discuss about the AngularJS versus Angular 17. We'll talk about the migration strategy and the tools, some important key features in Angular 17, building scalable and performant application, and best practice and the maintainability. This is going to be the agenda for today's webinar, right? So let's try to cover all as much as possible. Again, Angular is a very vast topic. It is one of the most popular framework for front-end development, or you can also see React and Angular are almost equally popular. But today our focus will be on the AngularJS, right? So in this today's session, in today's webinar, we explain how Angular has evolved from the AngularJS to Angular 17 and plus, why this changes is important, how the team can migrate legacy application, and how the modern Angular application should be designed for scalability, performance, and maintainability. So this session, you will understand the important features. Sorry. So in this session, we'll see what are the different important features. We do a comparison about the Angular. First of all, Angular JS and Angular 17 is not just a version. It is a completely two different framework. Angular JS was the first version was released, and generally whenever the new version was released in the market, it was majorly going to be the upgrade, enhanced version. But in the case of Angular, Angular JS and Angular 2 are completely two different frameworks. And few years ago, till AngularJS was maintained as a separate framework. Nowadays, been deprecated. It has not been Angular team doesn't maintain this AngularJS. They always recommend to move to the newer framework, which is Angular 17 and plus. So AngularJS was suitable for this time. What modern enterprise application required strong typing, better tooling, component-based architecture, performance optimized, testing support, and scalable projects structure. Now, if you look at the how we have structured this entire webinar, the first we're going to set up the web welcome and the context. Then we have the AngularJS versus Angular 17 plus. Then we talk about the migration strategies. Then we have some important key features, scalability and performance, and best practice. Then we in the end we can have a Q&A. Let me set up the context first. The first few minutes should be used to set the context, right? In this, we're going to see how many developers know AngularJS or older Angular versions, but they may not fully understand how the Angular has changed. So why this is important? When you say Angular modernization is important because many organizations still have the legacy AngularJS application running in the production. And these applications may still work, but they often suffer from the outdated architecture, poor performance, difficult maintenance, limited developer productivity, and weak type safety. So AngularJS application was commonly built with the scope, with the scope, with the scope controllers, services, filters, directives, and digest cycle. Right? This is some of the you can say the things that we use in AngularJS. These concepts work well for the smaller application, but as an application grow, they become harder to maintain. And that's where modern Angular come into the picture, which is built around the TypeScript, first of all, which give you the type safety. You know, the JavaScript, a wrapper is a TypeScript, which give you all the OOPS features and a lot of other features as well. So modern Angular is using the TypeScript officially, not the native JavaScript. Second, components. Now we also move from the MVVM pattern to the component-based architecture. And almost every modern framework of today, they use the component-based architecture where we can split a complex application into smaller pieces. And these pieces can be your components. Important thing is we have standalone APIs. We have Angular CLI support. We can use the CLI commands to generate the components, modules, services, etc. And Angular router, which is again important to set up the routes. In the modern Angular 17, we also get something called Angular Signal. Signal is basically used to make the component more light in weight. Lazy loading, improve SSR, right? These are some important features was introduced in the Angular 17. So Angular modernization is not just about changing the syntax. It is about moving from an old application design model to the modern front-end engineering model. Right? In AngularJS, developers often place too much logic inside the controllers and the template because that's still using the same old MVVM design pattern. An application will group the controller become too large, the scope become difficult to track, and the performance issue appear because of the too many watchers in the digest cycle. Angular 17 follows a more structural approach. It encourages the component-based design, storing the typings, feature-based architecture, and lazy loading, and also having a clear separation of responsibility. This is one of the main difference if you see in the Angular to the Angular newer version. If you look at the common differences, first language, it is still using a JavaScript, it's using a TypeScript. Second, main building block, controller plus scope, and here we have components. Let me give you a simple example. Suppose if you want to build a modern application, any web application, this is going to be a syntax, or this is going to be a typical layout of any application, of any web application, where we can have the maybe the header, maybe the navbar, the header, then we have sidebar, then we have the main content, then we have footer. You take any example, mostly all the modern application, they use this kind of a design. What the Angular suggesting as when we say component-based architecture, you can start splitting this into multiple subsections. For example, you can say this can be one section, this can be another section, this can be another section. Like this, you can start splitting break down the complex application into smaller components. And then we require somebody who can able to group all of them. That's going to be a root component. Every section that we have created, that's called component, which has its own logic, own design, all content. And you can maintain them differently. That means you can build a simple application, break down into smaller pieces, and the different team members can able to work on this simultaneously. Sorry. Let me give you one more example. Suppose if you go and search for Amazon, see this is such a huge application, correct? If you want to build this kind of an application, right, it's not easy for us to build. It has so many elements, correct? If I take this entire application as a whole, right? So if you want to design this application, what we can do is the first thing is we start splitting into small components. So maybe we can say this can be, let's say, this can be one component, which is going to be your, maybe let's say your header. This can be your navbar. This can be your slider. This can be another component. You can start breaking them into small components like this. If you see in this header, we still have many elements. So we can again split it into small pieces. So this can be one component. This can be another component. This can be another component like this. And then we can group them together to create the header. Then we can group the header, navbar, the sliders, and let's make the home page. So such kind of a huge application can be built using the this component-based architecture. That is the reason you will see all the modern UI framework, which can be your React, Angular, Vue.js, everybody using a component. You will find component everywhere. Another example can be, suppose for example, if you go and see there is a you might have played with the block games in your childhood, right? Assuming that this is going to be a block. So what exactly we mean by this? See, small these pieces are individual, independent. You can recompose them, rearrange them, and build something interesting. Similarly, you can say every small piece that we see here, they are components. You can put them together to build something else. This is the main design purpose of the modern UI framework. So AngularJS is based on the JavaScript and follow an MVC, MVVM style architecture. On the other hand, the Angular 17 and above is using the modern component-based architecture. Is that clear to you so far? So this is some of the difference. You can say MVC, MVVM, and component-based architecture. Change detection. In this, we have something called digest cycle. Here we're using a the optimize, and we are now in the newer version, we use Signal. Routing has been done using the ng routes, UI routes. Here we are using an Angular router package. Forms, we only had template-based, but here we had two approach, template-driven and reactive approach. State handling is done using a scope and the services. Here we use services, RxJS, Signal, and GRX. In this case, we are using the traditional package managers, for example, Grunt, Gulp, but here we're using the CLI. Angular has its own CLI tool, which is responsible to generate your components, modules, services, classes, start, stop, server, everything will be taken care by the Angular CLI. In terms of performance, it is watcher heavy. So if you keep on adding more watchers, which keep watching and observing your changes, that's going to affect the performance of the application. Here we're using the optimized rendering and lazy loading. We can load the component on demand. Now, if you see AngularJS and Angular 17 is not a simple upgrade, it's a component modernization. From scope-based JavaScript framework to the component-based TypeScript platform built for the enterprise scale. Now, if you look at the migration strategies, what do you mean migration strategy? First of all, if you see the migration strategy is going to be very important because it's not as simple as we just going to change and upgrade. The purpose is, first of all, in this section, we'll discuss about how the team can move from AngularJS to Angular, older Angular version to the newer Angular 17 plus. Migration should not start with the code. It should start with the assessment first. If you go with the migration mindset before choosing, right? Before choosing a migration strategy, the team should review the current application. The important assessment area is going to be your Angular, current Angular or AngularJS version. Your application size, your business critical modules, your third-party dependencies, your routing structure, your form complexity, authentication, authorization, build and development process, and test coverage, and UI component library. Because it is completely different. It is not just upgrading a version. You have to make a lot of structural changes because the entire framework is different. It's not the same for the framework. So migration can fail if the team only think about a syntax change. For example, replacing the ng repeat with at the rate for is easy, but understanding hidden business logic inside old controller is harder. So many AngularJS applications have business rule inside, which might be a controller, filters, directives, templates. Before rewriting or migration, the team must identify where the actual business logic exists. The first thing is going to be your big bang rewrite. What does it mean? In a big bang rewrite, the team will rebuild the entire application from the scratch in the Angular 17 plus. The old application continue to run until the new application is fully developed and deployed. That means it is going to be a parallel development. It's not something that we can take the old code and then migrate. It is going to be completely rewriting the entire application from the scratch. And we keep the older application in the production till the time the newer application is not up and running. This approach is going to be best when when you are working on a small application, a medium application, or poorly maintained application. Application needed complete UI redesign. Application with unsupported dependencies, or application where business logic is not too complex. In that case, we can go with the strategy number one. The advantage is first, the biggest advantage is a team can start fresh, clean folder structure, standalone components, modern routing, right? Strong type scripting models, lazy loading, better testing, better UI component strategy. But if you look at the disadvantage, the main risk is missing the hidden business logic. Legacy application often contain undocumented behaviors. If the team rewrite everything too quickly, important rules may be missed. So Big Bang rewrite can take long before business users see the changes, right? And coming to strategy number two, that's going to be your incremental migration. Now, what does it mean, incremental migration? In the incremental migration, the team will migrate the application modules by module or route by route. For example, you will take in the first phase, I will take the login. I'll rewrite the entire login part. Then I'll move to phase two, which is maybe a dashboard. Then the third is user management, then report, then admin settings. So we are not directly going to rewrite the whole application, but we are doing using a standard pattern, or you can say we are using an incremental migration, where we took one module by module or route by route and start migrating into the newer tech stack. Now this is going to be best approach for a larger enterprise application, production systems, application where business cannot stop the deployment, development, and team that needs controlled rollouts. If you look at the advantage, the first is incremental migration reduces the risk because you may start something new and you are not knowing what is going to be the challenge you may face. So when you take an incremental approach, you will going to address the issues whenever they come. You're not going to start something which may going to end in messing up everything. So you can do small incremental approach. You can take the small, some easy modules, try to rebuild them, test them, check them. Then you can pick up the next module. So since we're moving in incremental migration, it reduces the risk. Second point is instead of replacing the full application at once, the team can migrate one feature, test it, release it, and then continue. And this gives a business user confidence as well. We're not groundbreaking anything instantly over the night. But everything has a pros and cons. If you look at the disadvantage, the first thing is the main challenge is a temporary complexity. During the migration, the application may have old AngularJS part and the new Angular part as well, which is running together. This can create complexity around authentication, routing, because how are we going to share the state? There are two applications. You can say in simple words, there are two applications running parallelly. And when you want to share some kind of a state, you want to handshaking between them, that's become a problem. Sharing layout, sharing styling, deployment become a challenge, right? Then come the study number 3. That's called micro front-end migration. This is one of the popular strategy that we generally follow. In a micro front-end migration, the new features are built as a separate front-end application and then integrate into the large shell application. So in simple words, you can say we may have a main shell application which is act as a wrapper, under which we can have one application which is going to be Angular 17, which is a legacy module. Angular 17, another version that is user management. 17, report or admin. So we are not going to build one whole application. We are building multiple small micro front-end application, which they can able to interact with each other, keeping one of the main shell outer. This can be best for the larger enterprise portals, multiple front-end teams, independent deployments, long modernization timelines, and so on. So if you look at the advantages, micro front-end allow team to work independently because you might have heard about microservices. That is something we do in the backend side. On a similar words, you can say we have micro front-end, which is quite similar. So when we have a huge number of applications on the front end, we want to, or maybe some already they have multiple applications. Now they want to create something which is going to be they want to have a common something for all the applications. They want to bring everything under the one roof. Just a second. So that kind of application can be suitable because you can have an independent application for the billing, for reporting, for the admin, for the customer profile, for user management. These all are independent front-end applications which can run independently, which can maintain independently. Disadvantage can be, of course, micro front-end architecture need governance. Without the governance, the team may create inconsistent UI, duplicate dependencies, and different coding style. So some of the important governance areas which include here is shared design system, authentication strategies, routing strategies, versioning, shared library, etc. Right? In this case, you can use the tools like, for example, we have the Angular update guide, which can give you the version specific update instructions. It helps the team understand what need to be changed when moving from one Angular version to the another version. So there's a tool like we have the ng update, right? ng update is basically your tool provided by the Angular, right? The ng update command update the Angular packages and apply automated migration where possible. For example, when you say ng update Angular @CLI added Angular core. So for example, in that case, we want to move from 17. So Angular CLI is used for creating the projects, generating the components, running the development servers, building the application, running the test cases, etc. So in that case, you can able to use this kind of a tool to update your Angular versions. Correct? Then we have something called ESLint and TypeScript. Now ESLint help maintain the code quality. You might have heard seen this in a multiple project. ESLint. ESLint help the maintain code quality by it can identify the unused variables, bad coding practices, inconsistent style, unsafe patterns, or incorrect imports. Sometimes you import something but you never use. You get an error from the ESLint. Sometimes you have declared a variable but not use that again you get an error. Sometimes you have not defined the type of the variable that again you get an error. So this is basically maintaining the coding standards. Correct? So we can also use Angular update guide, which officially step-by-step version update guidance at the Angular update.angular.io. This is a website you can refer, which is going to give you the updated step-by-step updates, how to move from one version to another version. Okay, next we have the Angular DevTools. Basically, Angular DevTools help inspect the Angular application in the browser. It can help use to inspect the component tree, profile changes, debug performance issues, and understand the component hierarchy. Because you may have component within the component. So you want to understand the component hierarchy as well. Then we have something called Lighthouse and DevTools. So Lighthouse basically is useful for checking the performance, accessibility, SEO, best practices, and progressive web readiness. This is another important tool that you can use. Then come the Cypress, Jest, or Playwright. These tools are used for end-to-end testing. Now they help you to validate the full user journey, such as your logging, your search user, your create user, update profile, etc. We have Jest, also Karma. These are the testing tools we can use. Generally, when we want to migrate, one of the best strategies we follow is to first write the test cases. And with us, every change, you can run the test case and can see, does it going to break anything existing or not? If that, you will go and fix that issue first. Instead of doing testing in the end, you can follow TDD approach, test driven architecture. Then we have Storybook. Storybook basically is a use for the component driven development. It allows the team to build and test the UI component independently. It is useful for your buttons, your tablets, tables, your forms, your dialogues, cards, and any design components. Is it clear everyone so far? I hope guys you can able to raise the to give me thumbs up if you're okay. I hope you have the access to the reactions in the teams. Yeah, I can see one thumbs up. What about the others? Okay, fine, perfect. Next, we want to move to the some migration command. You can see we have ng version that is used to check the version of the Angular. Then we have the ng update to preview the available updates. And then we can say ng update Angular CLI Angular code. This is going to update your CLI and the code together. And then we can target a specific version by mentioning the version name also. ng update Angular CLI at the rate 17. That means we are targeting to upgrade to Angular 17 version. Because you might have seen 17, 18, 19, and then so generally one more important thing is the Angular team when they released the Angular 2, right, many years ago, they also promised that now they're going to have the release twice in a year, right? But they also have promised now next versions or upgrades will not going to be groundbreaking as they did in the Angular 1 to Angular 2, right? So all the version that we are using now till now 19, I think the latest one, they all enhancement of the Angular 2 version only. There's no structural change. They keep on improving the tooling part of the framework, but they are not making any groundbreaking changes. Now, when they keep on upgrading a new version, you can target a specific version. You have to do a proper due diligence. Then when you move to this version, does it going to break anything? If not, then you can safer to move ahead. So migration should not start with the code. It should start with the assessment, dependency audits, architecture reviews, testing strategy, and rushed migration is failed migration. This is the important thing you have to keep in mind. Okay, so before I move to next topic, I want to take a 5-minute pause. I want all of you to just recollect what we have covered so far. Any doubt, any questions, do let me know. Okay. Okay, team. Now let's move to the next part. We'll talk about the key features in the Angular 17. Just give me a minute. Okay. Now, if you look at some important key features, the first is a standalone component. If you see the Angular 16 version doesn't have the same feature. Whenever we want to create a new module, so a new component that has to register with the ng module. So it is unnecessary that we will sometime we have all the component has to go with the ng module. So they remove this in the Angular 17 and come up with a new concept that's called standalone components. So standalone component basically you can say uh, allow developers to create the Angular components without declaring them inside an ng module, right? So you can simply just say component, selector, template, and then we can add one more attribute that's called standalone true. That means this is going to be individual standalone component doesn't need to register with the ng module. So there's no dependency on the module. It can work as a standalone, which means it is a less boilerplate code required, easy for lazy loading, better tree shaking, and simple testing. Simple for testing as well, right? Earlier Angular application heavily depend on the ng module. The feature usually needed a feature module, then feature routing module, component, services, shared module. But with the standalone component, Angular reduces its boilerplate code. And you can now create the component directly, components, directives, and pipes that are self-contained. The benefit is less boilerplate code, simpler project structure, easier for lazy loading, better tree shaking, easier for testing, and clean feature boundaries. In the older Angular application, every simple feature required creating or updating a module. And with standalone component, the component itself can declare what it needed. And this makes the application easier to structure and easy to lazy load. That's the first important feature you will find in Angular 17. Second feature, built-in control flow. Angular 17 introduced a new template control flow syntax. Instead of relying on the structural directives like your ng if, ng for, ng switch, they now have @if, they have @for, @switch. Earlier we used to have asterisk ng if, asterisk ng for, asterisk ng switch. But they have replaced it. Now we have the @if, for, and switch. Now, if you look at the if also, it's very simple and straightforward. We can simply say @if, you can have a condition, and then you have the else. That means it can render either this or either this. Similarly, for the for also, we can use the track by, which is also going to be enhanced version, which is going to be responsible to make this, make the code more readable and maintainable. Right. So this is another important feature you will find inside in the case of the 17 version. Next come the deferrable views. What is in deferrable views? Now, deferrable views allow Angular to deploy the loading part of the UI until they are needed. Right? For example, you can see here we use defer on viewport app heavy chart. Placeholder, chart, placeholder, loading chart, error, you can get the error. The point is the sometimes my page take time to render. So I want to display some kind of a alternative text. Sometimes a page contains heavy components that are not immediately required. For example, your charts, your reports, your maps, your comments, large tables, admin widgets. So instead of loading everything during the initial page load, Angular can defer loading until a trigger happens. Suppose user click that I want to see the page or see the view or see the map, then only it will be visible, so that make the performance of your page better, because we are not trying to load everything initially. There can be some different triggers. We can have the on idle state, on the viewport, on interaction, right? You can use this kind of trigger, defer, on idle, viewport, interaction, hover. When you take your mouse or hover any of the element, then it will going to be triggered, right? Now, in this case, if you see on idle, that means loading when the browser is idle. Best for non-critical content. On viewport, loads when the component enter the viewport. Best for below the fold content. On interaction means the load when the user interact with an element. Best for tabs, accordions, and optional sections. On hover, load when the user hover over an element. On timer, load after a fixed delay time. And when condition, also when you have a kind of a condition. The benefit is, first of all, deferred view improve the initial page load, bundle loading, and perceived the performance, user experience, and your core web vitals. The fourth important feature is going to be the signal. Now, signal you might have, if you have come in .NET background, you might have heard about signal. Signal is basically like a WebSocket. But how the Angular uses signals? Signals are Angular modern reactive state mechanism. Just a second. Okay. So signal basically I said signals are the Angular modern reactive state mechanism. They allow values to be reactive and automatically update the UI when the value changes. So this is also going to be you can have some kind of computed values. You take some two values, you do the computation. So whenever you change the input, we want to change the output. It's more like a reactive memorization. Use memos, right? So for example, you might be having a sorry. So you might be having a let's say count signal 0. And when we double count, you will going to compute the value and now you're going to say count multiply by 2. There's a button which you're going to call the event called increment. And whenever you want to click the button, I want to increment the value. Correct? So basically what will happen, a computed signal derived a value from the another signal. That means when the count changes, the double count update automatically. So the benefit is first, simple reactive state. This doesn't have to go with the entire rendering of the component. We are just trying to play with the values. It is fine-grained reactive. That means it's just going to specifically pick up that value and modify and update. So we have a cleaner component state. We have less boilerplate code and better readability and better performances. Now, where do you signals? Again, it is also going to be very important that where we give signals. The signals can be used for component level states, for UI state, for filters, for selective tabs, for search text, for derived values, and for local dashboard calculations. So there we can, when we make some changes, you want to see them, reflect them immediately without making the entire component re-render. There we can use a signal. Let me give another use case. Suppose you have a product dashboard, right? You can use Signal for products, select the category, search the text, filter the products and total products. Now this make the UI reactive without manually subscribed to observables for every small state changes. Because earlier we used this something called RxJS, which is again has to be a lot of code need to be write. They have simplified this. Now with the help of Signal, I can able to achieve the same. Next comes another important feature that's called SSR or hydration. What is SSR? SSR stands for server side rendering. What does it mean? In the server side rendering, the server will generate the initial HTML and send it to the browser. Mostly in the front end, we do everything on the client side. But now assume you have a very data extensive application. Whenever you want to make a call, you want to get a huge amount of data, and that data need to be processed, put in a proper format, and then we display. Instead of this, that's going to put a lot of load on the front end side. Now this thing we can do on the backend side. So we will going to make a request, backend going to process the data, put them in the right format, and directly going to return the HTML. That will directly go and display on the front end. So there's no pressure, no hard work for the front end for to do, right? Now this will improve your first page load. Now in the first page, you take an Amazon, there's so many things they are doing on the home page. They want to get the slider, categories, products, best deals, those things, right? I will not load one by one on the front end. I'll directly going to render or compute everything on the back end, return the simple HTML with the data, and that will display. So that we're going to reduces the first page load. And also it is going to be good for the SEO because when you do it on the backend, I can also add the SEO features as well. And then also give you the user better experience and performance on the slow network as well, because now we are not making anything on the front end side. There's something called hydration also. What's hydration? Hydration means Angular take the server rendering HTML, make it interactive in the browser. Because without the hydration, the browser may need to recreate the entire page. With hydration, Angular reuse the existing HTML and attach the behavior to it. It's as simple as suppose you might be having some kind of a template and you just need to add the content as needed. Now, why SSR and hydration matters? Because they are used for public websites, for e-commerce websites, for content heavy pages, and for SEO focused applications, right? Now let's take another example, another topic that's called building scalable performance. So if you look at some of the important features that we discussed, the first thing is standalone components we discussed. Now we can make the component to be standalone. They doesn't have any dependency on the app module. Second, we discussed about the built-in control flow. Now we have the more simpler and we have the built-in control flows. Next, we have the deferrable views that can suspend your views for some time. When they trigger, only then they will be loaded. We have signals, which is going to be make your pages, your values more reactive. And then we have SSR and the hydration, which is going to be server-side rendering. Now, if you look at another topic, any doubt anybody have so far in the previous topic? Features of the Angular 17 are clear, all of you? Team, give me thumbs up if you're okay, fine. And if you want to ask anything, you can put your query in the chat window. Okay, perfect. Thank you everyone for the response. Let's move to the next topic, building scalable and performant applications. Now, what does it mean? It means a scalable Angular application is not just an app that works. It should be easy to extend, test, debug, deploy, and maintain. Build scalable. That means we want to build something that is not going to solve the purpose of today, but my growing demand also, my growing need as well. It should be extendable. It should be easy to test, debug, deploy, and maintain. So what does a scalable means? A scalable application should be easy to extend, easy to test, easy to debug, easy to multiple team to work on, easy to deploy, easy to collaborate, optimize for performance, and organizing by the feature and business domain. The first starting point is going to be how we want to structure the application. What is going to folder structure? Because you may not going to work alone. It is going to be the part of the team which have to work together. How are we going to distribute the task? So in that case, we need to make sure that we going to follow a proper structure, a proper folder structure. Now see, in this case, if you see, we have the app. Under the source, we have the entire source code of the application. Then we have the app. Then we have the core, which contain my core features, which consist of the auth, the guard. Then we have the interceptors, services layered. Then we have shared, right? So the core folder contain the application wide singleton services and the infrastructure, which use this folder for things across the use across the whole application. Authentication, token interceptors, error interceptor, auth guard, layout shell, app configure services. Then come the shared. What does it mean of shared? The shared folder contain reusable UI and the utility items. Correct? For example, your buttons, your tables, your pipes, directives, formatters. Now, do not place any business specific logic in the shared. Shared means it has been shared and you can directly just go and use it. What are things you are going to be using across everything, you can put in the shared folder. Then come the important folder that's called feature. We should try to build the everything feature by feature because you want to make it extensible. For example, today you want to add a authentication feature. Tomorrow you want an authorization, dashboard. So those things has to be built in a feature wise. So you can have a feature folder, let's say users, orders, reports, billing, admin, and build one after the other. Or you can ask the multiple team to work independently on the feature. You may have two developers, one is working on the admin, one is working on the billing, other is working on reporting, that's it. So feature folder contain the business modules or your domain. And each feature should contain its own pages, components, services, model, and the route. That means that folder feature consists of everything what you need. If you look at this users has a page, component, services, model. It's going to be like a complete feature code will go inside this users. Make sense? Next come the lazy loading routes. What is lazy loading? A lazy loading is a very common thing. If you have a might be already have aware or not, then let me know. So lazy loading means loading a feature only when the user need it. You may have 100 features in your application. Do you think it's a good practice to all load all the 100 feature in one in a page load? First page? No. You may have, let's say, profile update. That's a feature. But how many people profile they update the profile? They generally open the profile when they sign up and maybe never come back. You may have the option in the profile to update your picture, write the status, and so on. Change the password, change the email, but nobody use it mostly. That is an important feature, but it has not been used widely. Why have to load this feature initially? Because that will increase the boot time. So lazy loading means loading a feature only when the user navigate to it, right? Now, why lazy loading is important? Because without lazy loading, the browser may download too much JavaScript during the initial load. And with lazy loading, only required feature is loaded. The benefit is first, of course, some smaller initial bundle, faster startup, better user experience, and better performance for the larger application, right? These are some of the important features about the lazy loading, correct? It is also good for performance as well. Now, if you look at some performance practices, lazy loading come on the top. One of the very common thing that most of the people will use, lazy loading. Use lazy loading for feature routes. Do not load the admin, report, dashboard, user management modules all at once if the user does not need them immediately. That's the first thing. Second, deferred blocks. We discussed defer for heavy UI section. Maybe the charts, the reports, the maps, export reviews. Some analytic widgets may take time, so you do not need to load them initially. You can use defer for heavy UI sections. For with track, again very important. If you have worked with the Angular in the past, this feature is there in the Angular almost all the version mostly. So basically, track by is another important feature which will be tracking the changes. Generally, what happens is whenever you make a small UI change, it will re-render the entire whole table, whatever you're trying to use with the for. By using the track, I can optimize my listing, which is going to re-render only the section which get updated. Very common thing. Then we have on push change detection. On push change detection reduces the unnecessary checks. It is useful for the presentational components that depends on the input, your user table, your product card components, etc. Signal for the local state, again very important. Signals for the local state to make uh, your data more reactive. Signals help to manage the components and the local UI state efficiently. Search text, selected items, toggle state, filters, etc. Avoid template function calls. You can say because this function may run repeatedly during the change detection, you can avoid them, right? Route guards, again, very important. HTTP interceptors, just for you want to make sure that we are intercepting every changes that you made, you can use a interceptors. Bundle analysis, that means detect all and eliminate the larger hidden dependency, which may going to cause application, affect the application boot time. So these are some performance best practices. Okay. This is something we discuss. Avoid heavy template logic. You should not try to put logic like this. Call in the function the template. Recalculate on every change direction. So do not call the functions directly. You have a logic within the component that just need to call here the property itself. Okay. Anything? Any doubt? Any question? If you have, feel free to ask now. We'll take a 2-3 minute of pause. Then we start on next topic, state management. Okay. Okay, team. Now let's move to the next topic, and that's going to be state management. Now, what is state management? So usually in any application, the state is going to be the data that we're going to use in the application. Okay. So first of all, if you see, the state is basically a data that has been managed by the application. Now, in this case, there are multiple options. We have component state that is used by Signal, shared feature state that is using a services plus Signal or the RxJS, or server state that is going to be using the API service plus caching. Then complex enterprise using the NGRX, which is like a Redux that we use in React. Form state is using a reactive forms, and for the URL state, we use the query params plus route params. Correct? You have to choose the right tool for the right scope. For example, for the what kind of a state you want to manage. You want to state centrally you want to manage, then you can use the NGRX. It is if it is in a per component, then you can use the RxJS, right? So it depends on what kind of application you are using. Accordingly, you have to select the right state management services. For component state, use Signal. For shared feature state, you can use the Signal or RxJS. For server state, you can use the API service with the caching when needed. For complex enterprise state, you can use the NGRX or Signal Store, which is like a Redux. For form state, we can use the reactive form, and for URL, you can use the query parameter or the route params. So some of the best practice in maintainability is going to be your first modularity, consistency, strongly typed, testability, easy to onboard, right? And then easy to refactor. First of all, if you talk about the maintainability principle, the maintainable Angular app should be modular, consistent, strong type, testable, predictable, easy to onboard, easy to refactor. Right? So first of all, if you look at, you can see component-based best practices, avoid large components. A component should not be do everything, right? Avoid component that handles. When one component does too much, it becomes hard to test and maintain. For example, API calls, your validations, your permission logics, formatting, filtering, etc. You can prefer a separation between the user list page, which can have the user services, user filter component. Do not try to put everything in a single one place. You should always try to make a choice between smart and presentable components. Smart component means a component. Smart component is responsible for the logic, which can handle the API calls, state, route parameters, navigation, business rules. On the other hand, the presentational component means a presentational component focus only on the UI. It handles your inputs, output, display, and user events. Some of the best practice of the services. Now, services should be used for the clear third-party interaction or for API calls or for adding a business logic because that help you in testing the code separately. You can avoid the mistake where you are returning any. It should be returning a proper structured output. Hard coding URL everywhere is not good practice. Huge service also not a good practice. Try to break down into service into smaller pieces. Then we have type safety. Now type safety means instead of writing just simple user any, you can have user of specific type. You can make the interfaces for that, right? We should avoid using the any like this. You should try to give an interface, like say interface user, and can have a structure for the user. Now we'll come back to the code review checklist. What is a code review checklist? That means this is going to be some checklist that you have to keep in mind when you're doing a code review. First, feature is lazy loaded. Second, is a component too large? is not used anywhere. Are interface and DTO defined? For uses the track. Heavy component use differ. Is error handling implemented? Are services separate from the UI? Are subscriptions clear up? Are routes guarded? Any naming convention follows. So this is something you have to keep in mind when you talk about the code review checklist, right? In the enterprise project, quality should not depend only on the individual developers. The team should have repeatable review practice. So the code review should check architecture performance, type safety, security, and the maintainability. Is it clear, everyone, so far? Any questions? Okay, team. We'll take a one case study of how we do going to plan or what is going to roadmap looks like about the Angular modernization roadmap. Okay. Now let's see. First of all, let's take a scenario. There's a company has an old AngularJS employee management portal. In the current system, they have AngularJS 1.6, which consists of controller and the scope, manual gulp build, no TypeScript, limited testing, slow employee list page, and large controller files and old routings. That has to be replaced into Angular 17 using a standalone components, feature-based folder structure, lazy loading, Angular modular routes, reactive forms, signals, deferrable views, and centralized API services. So what are you going to do in the phase one? The phase one is going to be the assessment. This is going to be the entire roadmap. The assessment. Assessment means understand the current application before the migration. So in this case, what is going to activities you will perform? First, identify the modules. Review the dependencies. Review the dependency. Then we have to identify the modules, review the dependencies, analyze the business critical workflows, review current routing, and check the test coverage. This is done in the first phase, that is going to be the assessment, right? Now, for example, an old employee list page may look simple, but it may contain searching logic, role-based visibility, export logic, pagination, filtration, etc. Assessment will help you identify these rules before migrating starts. Then come the foundation. Now we need to create a base Angular 17 plus application structure where you have to create an Angular project plus workspace, set up the routing, the layout, authentication shell, shared UI components, and set up the API service pattern. And do not start by randomly migrating the pages. Then come the feature migrations. Now migrate feature one by one. You should not try to target to implement all feature at once. You should try to go one by one. For example, for example, login, employee list, employee details, admin approvals, reports, validation. So login is an often migrate easy because it is an entry point. Employee list is a good next candidate because it will usually include real world features like API calls, search, pagination, exception handling, etc. Then come the fourth phase, performance optimization. The goal is to improve runtime and in loading performance, where you can add the lazy loading, add defer, list rendering, analyze the bundle size, and improve the core web vitals, right? Do not load all the features at the startup. Use lazy loading for the routes and use defer for heavy reports and charts. And then come the fifth phase. That's going to be the production readiness. That means prepare the application for real production rollouts. For example, regression testing, security testing, accessibility review, CI/CD pipelines, tagging the deployment, production rollout, and etc. Migration is not complete when the code complies. Production readiness means the application is stable, secure, tested, and deployable and unstable, right? So in this case, you can have the complete flow of the authentication, authorization, and so on, right? This is going to be then the plan for the revamping. from migrating the application from the legacy to the modern application. Is it clear, everyone? Understood? I hope you understood all the things that we have covered. Any doubt, any question if you have, feel free to ask now. So team, we are done for the all the topics. If you want to ask anything, you can ask the question now. So team, I hope all of you enjoyed today's session. If you want to ask anything, feel free to ask now. You can unmute yourself, you can discuss, or you can put your code in the chat window.
Varun, I see one question in the chat.
Okay. Please elaborate more on the MFE and how to MFE communicate with each other. So basically MFE you're talking about the micro frontend, right? So micro frontend, there are no two micro frontend. There's a one micro frontend where we go generally going to have the micro frontend shell. Let me explain you with an example. Let me share my screen once again. Now we'll take an example of a micro frontend. Assuming that you are building a micro frontend where we're going to have a micro frontend which is going to act as a micro frontend shell, under which you can have your login or SSO authentication, and then be multiple applications, right? So in that, again, there are multiple ways we can implement this, but one of the most commonly implemented option is we can create one micro frontend shell which is responsible to handle, right? Which is responsible to handle the all the authentication authorization at one at the level on the first level, and then it can maintain the your authentication authorization, and then according to the request of the user we can navigate to the different applications. If you look at an architecture where the large front-end application is divided into multiple smaller front-end application, each small front-end application is called a micro front-end, right? And each micro front-end can develop, test it, build, and deploy independent. You can say these are your independent application, and it does not need to be in a Angular. It can be one in Angular, one in React, one in going to be Vue.js. It depends. So micro front-end is commonly implemented using a module federation or native federation. A model federation allows separate build front-end application to expose and consume the code at runtime. And the shell is usually called a host. This is going to be the host, the outer block. And MFA are called remotes. Now, why do we need this MFA? Because MFA is useful when one front-end application become too large. And without the MFA, a large application may become very long, one large code base or deployment. With MFA, you can break down into smaller pieces, and now they can able to live as an independent services. Is that clear, everyone? It can be, let's say, a dashboard, user management, your claims, reports. They all can be a separate micro front end, and they can be developed by different teams also. So it's easy for us to make the application more scalable as well. Right? Is that clear, everyone? Anand, is it clear now?
Yes, but I just want
Oh,
to know the communication between two MFE when you use the shell, because we already
this
have the other design pattern also, right? Like
correct.
publish and subscribe you have,
Yeah.
or you have another custom events also.
Mhm.
But why you go for the shell? What's the benefit I get when I go for shell
So
instead
shell
of
is going to give you the
publish and
common layer.
subscribe?
So shell basically give you the common layer. We are not going to have, because they're two independent services. You cannot have you cannot have the custom events which can able to talk to each other. So the idea is we going to it is mostly going to be your main front end. The main, you can say, the shell is going to be responsible to maintain the state, which data we want to share across multiple micro front ends, different applications. It's
Okay,
not directly going to be between two applications. It is going to be with the help of the your shell. We can able to communicate. Shell responsible for routing between the two applications. And
okay.
for that, we use a model federation.
Does
Okay.
also does also it preserve the state of the MFE? Does
Mm-hmm.
they are available or not, like that?
And did you come again? What is the question
Mm.
again?
And does Shell also have a capability to manage the state? Does
Yes.
MFE is available, or some are the down, some are up and running?
Yeah, yeah.
Okay.
That logic you can write. Suppose if in case you have one of these services not running, one of the app is not running, you can reroute it to, or you can have this fallback URL, which can able to trigger the another services, which might be a kind of a central service to handle all the errors.
Uh, okay. Got it.
So if everybody's mic's been enabled now. So if you have a question, you can just unmute yourself and ask.
So Shell also one kind of Angular applications, or is it something different design pattern?
So basically, shell is like a maybe like a wrapper. It's also going to be an application where we can under which we can have multiple micro frontend applications. So there are different patterns we generally use for the communication. For example, we have the route params, which is navigating from the MFA to another. We have shared context, which is going to be the shared login, user, roles, tenancy, permissions. We have an event bus also. We have backend API also, or we can use a local storage as well.
Uh, Good. Thank you. Thank you, Varun.
Thank you.
And Varun, there are multiple approaches like
Mhm.
model federation, native, and then
Mhm.
web component. How will you
Correct.
know which one to use?
That depends upon the application. It is not the case that we can say this is going to be better in every scenario. You need to analyze the application. Accordingly, you have to plan which one is going to be better in your use case. So it is not going to be a straightforward that we always use this approach. It always depend upon the application to application.
Okay, so
Okay.
like, suppose we have
Mhm.
model federation and web components. So
Mhm.
which kind of application we can use model
Sorry, come again.
federation? Like, can you give example like for which kind of application we go for the model federation or web component?
Mostly we use model federation when we want to have a strict enterprise level application, where we want to have the authentication authorization on the top level. So generally we have a user management MFA, which can have the user claims, view claims. Then we navigate to the claims. Then we can go to the shell load claims, and then we can have the different applications which is going to be relevant for that particular user. So for the enterprise level application, we mostly going to use a model federation. Okay, is it clear?
Yeah, because now we are going to work on the MFP. My
Okay.
application is standalone Angular. So I'm
Mm-hmm.
going to use the web component approach. That is why.
Okay. Again, it depends. I said there cannot be, first of all approaches are fine. It depends upon your expertise, your requirement, which one you can choose. I mostly work the model federation, so I prefer the model federation. You might work with a different approach. You can use that as well, unless until you find any kind of bottleneck.
Okay, sure.
Yeah. Anything else, team? Any other doubt? Any other question?
Any other question? If not, we'll wrap up this session at 4:25. So,
Sure. Thanks, everyone. I hope you enjoyed the session. Thank you, everyone.